Alright guys, it's 10:30, so let's go ahead and get started. So today we're going to talk about teaching study skills. So today's agenda is this presentation. So this is a talk that I've given 3 times now. I gave it to my students last fall. After our first exam, I gave it to the students last spring before the first exam, and I was asked to give it at a conference this summer. So this right here is your recipe to be successful in Chem 1320. So let's go ahead and get started. So any basketball players here, or anybody who used to play basketball? Well, if you have, you've probably heard of a drill called the 3-man weave. But if you haven't, here's a video showing how the 3-man weave is ran.
If you start playing basketball on a team, whether it's at the boys club, the park and rec center, whatever the case may be, this is a drill that you're probably going to do. It's a great warm-up drill, and it incorporates a lot of the skills that we've been talking about, whether that be shooting a layup, passing, or dribbling. Okay, here we go, guys. 3-man weave. Good. There's a rebound right there, a pass. Okay, and we're still going down the court. Let's come back. Let's come back and let's dribble. Okay, good. As we're coming right now. Take it to the hole, KP. Put it on the floor.
Okay, so notice one of the things that he said was this is a good warm-up drill. And that's true, it is a good warm-up drill, but is just doing 3-man weave going to be enough to get you ready for a basketball game, a full 5-on-5 game? No, the answer is no, because first of all, it doesn't replicate a game. There's not even any defense involved in the 3-man weave. So here's a more advanced drill, something a little bit more modern, called the 3-on-1 transition drill.
The 3-on-1 drill is a fun way to develop your players' freedom to create and finish scoring opportunities in the open court. The offense has a significant numbers advantage that increases their chances for success, but also opens up more space for passing possibilities. There are no set teams, and the single defender converts to offense with the 2 players at the front of each corner line.
Okay, so that was a little bit more advanced, right? But that's still not quite enough to get you ready for a full basketball game, right? It's still just 3-on-1. It doesn't replicate a full 48 minutes of basketball. So how do you replicate that? You have to scrimmage. You have to play 5-on-5 to get ready for a 5-on-5 basketball game. Okay, so my question for you is, how are you studying? So I have a feeling for a lot of your classes you've been doing a 3-man weave. So what do I mean by that? So you might have online quizzes like we have in this class. You might have example problems in the book or homework problems like we do in this class. And you might be doing them with your notes out or your book open or my PowerPoints up on your computer. You might be reading the chapter or looking over the PowerPoint. So I have reading in quotations here because you're probably reading it like you're reading a novel, like you're reading Harry Potter or something. Or you might be studying for X minutes a day, whether that's 30, 45, 60, you have a set amount of time that you are spending each day. Some of you might be doing a little bit more. You might be doing what's synonymous to a 3-on-1 transition drill. So you might be making an outline or a study guide. You might be rewriting your notes from class over and over. Or you might even be reading the chapter while taking notes or making flashcards. That's great. I would recommend you keep doing all of those. But there is something missing. The 5-on-5 scrimmage. So you have to practice under game conditions to get ready for a basketball game. Well, chemistry is the same way. It works exactly the same way. You have to work problems under test conditions to get ready for the test. So what do I mean by test conditions? So I mean no notes, no book, no internet, the same calculator you plan to use on the exam, and you have to have time constraints. So in other words, you have to quiz yourself. So this is how I studied as a student. And I want to give you a little bit of a disclaimer here. This doesn't work for everybody. This is not a one-size-fits-all thing. So if what you're doing or what you're not doing is working and you're a straight A student, keep doing it. But if it's not, give my method a try for the first exam. So step 1, you're going to make digital flashcards as you read the chapter. So this means doing it at your desk or a quiet area, not laying in bed or sitting on the couch, something like that. So if you like paper cards, that's fine as well. I just prefer digital flashcards, and I'll tell you why when we get towards the end of this presentation. So anything you don't understand, don't just skip over it. You need to supplement it. So you can look it up online. Wikipedia is a great source for a lot of the basic chemistry we're doing in this class. There's a lot of great YouTube videos, or even better, send me an email. I love doing chemistry. So step 2, I want you to do all the example problems listed in the book. So this is our 3-man weave. And I want you to attempt the problems on your own first. So don't follow along with the book to see how the book does it. I want you to attempt it on your own. And then if you get stuck, then you can look through the chapter or look through your flashcards or look through my PowerPoints to see if you can get some help there. Don't look at the answer. Then once you finally are able to figure it out and you're able to formulate your own answer to the question, then check the book and see if you got the answer right. So step 3, I want you to study your flashcards, and this is the 3-on-1 transition that we're going to do. So I like to do these in chunks. So when you have new flashcards, I study about 10 of them at a time. If I'm going through older flashcards, about 20 at a time. And now you can't just read these. You have to actually use this as an opportunity to quiz yourself. So what I want you to do is look at the front, ask yourself the question, think about it, then give an answer, then turn over the card and see if your answer is correct. And I want you to repeat this until you don't miss any. So be able to go through a chunk of 10 or 20 at a time without missing any. Now step 4, this is where we're going to work homework problems. And we're going to work quiz problems, and we're going to do it under exam conditions. So this is our 5-on-5 scrimmage. So what is this again? This means no notes, no book, no internet. So no resources in front of you while you're doing this. I want you to use the same calculator that you're going to use on the exam. So don't use the calculator on your phone. Don't use the calculator on your computer. Do not wait until the first exam to learn how to do everything in your calculator. You need to learn that now. And you need to time yourself. So our exams are going to be 75 minutes, and you're going to have somewhere between 25 and 50 questions, depending on how many steps there are to each question. So you do the math, you can't afford to spend 2 or 3 minutes on each question. And then I want you to keep working problems until you're getting them correct under the exam constraints, not until you kind of understand. Don't get to a point where you're kind of comfortable and stop. That's the point where we need to ramp it up a little bit. And now this might be the most important part, but unfortunately this is something that I didn't learn as a student. I had to learn this after I got out of college. And that is continue studying after the exam. So I don't want you to learn some chemistry this semester, just cram it in and then forget it all, and then when you see me in the hall next semester, not be able to tell me anything. So what I want you to do is actually learn this material. I don't want it to be a short-term thing. So I want you to continue studying after the exam using some kind of spaced repetition model. So, and that's not just important for when I quiz you in the hall after the semester. That's important for this class because every chapter in this class is going to build on the previous chapter. So we're starting off with 2 organic chemistry sections. And then from there we're going to carbohydrates. And the carbohydrates is going to build directly from organic chemistry. Then we're going to lipids, and that's going to build directly from organic chemistry. Then we're going to proteins, and that's going to build directly from organic chemistry and a little bit from the other 2 the other 2 biochemistry chapters that we've already done. Then we're going to do nucleic acids, and that's going to be a lot of carbohydrates, a lot of proteins, a lot of organic chemistry. And then we're going to finish up, bring everything together with metabolism. So just because the first exam is all organic chemistry, it doesn't mean we're done with the organic chemistry. It means we're about to start applying the organic chemistry to biomolecules. So why do I like digital flashcards over paper? Well, traditional paper flashcards are fine. If you like doing that, that is great. I will not stop you. But there are some pros about digital flashcards I want you to know, and maybe you'll consider switching over. So first of all, it's easier to edit. You can do this on your computer instead of having to make a completely new flashcard. They take up less space. It's a lot easier just to bring your phone to class that has all your flashcards on it rather than bringing a big stack with you. You can include images and animations, and you can automate the spaced repetition that I recommend you guys doing. So what kind of flashcards should you make for this class? So here's some example flashcards I made using an app called Flashcards Deluxe. So here's just a basic question and answer flashcard. So on the front we have the question. So how does the length of a hydrocarbon chain impact its boiling or melting point? You guys probably don't know the answer to that right now, but I want you to sit there and think about it. And then after about the 5th lecture, you should be able to answer this. And the answer is, the longer our carbon chain, the greater the surface area between identical molecules, the more London interactions that can occur between these molecules, thus higher melting and boiling points. So another thing we're going to do a lot of is naming. You're going to have to name a lot of molecules in the organic chemistry chapters. So you should make flashcards for that as well. So here's an example of how to name a geometric isomer or name an alkene. So we have the picture of the molecule on the front, and then on the back we have the name trans-2-pentene. You're also going to be doing a lot of reactions. So here's an example that will be probably on the first exam. How many unique organic products are produced when this organic molecule below, this aromatic molecule, reacts with bromine in the presence of an iron catalyst? Okay, well, we know an aromatic substitution reaction, the bromine can substitute for a hydrogen on any part of the ring. So how many unique products are made if we substitute on any part of the ring? We get 3. There's 3 different unique products we can make by substituting a bromine for a single hydrogen on the aromatic ring. Another great thing you can do is we're going to have some online quizzes that have questions like this. Take a screenshot of it, then take a screenshot of the answer. And so you can really study the quiz type questions until you get them down. And probably my favorite is using animation. So when we get to proteins, you're going to have to explain to me how a sodium-potassium pump works. And here's a great animation from Pearson that does it for you. Alright guys, so that's it for today. I hope you enjoyed this. I hope you learned something from it. I hope you're able to implement some of this, and we're actually going to implement some of this together in our lecture before the first exam. And so I will see you guys in class on Monday.